Hello, I am by name Prajapati Heli and I'm a student in software engineering, and my project name is actually face recognition system. The problem nowadays, security plays an important part in day-to-day life. The use of internet in human life has become the day-to-day activity, and the use of internet of automatic devices has increased also. All transactions should be secured and no hacking should be taking place. Hence, to avoid this hacking and theft of information, I have introduced a face recognition method. It can be applied in many fields such as security issues, authentic users, and in real-time systems also. How artificial intelligence will be applied. Well, face recognition uses AI algorithms and machine learning to detect human faces from the background. It typically starts by searching human eyes, followed by the eyebrows, nose, mouth, nostrils, the iris. Once it's all done, the validations are done by using large datasets containing both positive and negative images to confirm that it is a human face. Then the face capture process transforms this information into a digital information which is database, and your face analysis is turned into a mathematical formula which is called face print. The face print is then compared against a database of other known faces. Here I will be implementing the convolution neuron Newton to automatically create dataset and recognition with the use of graphic user interface. The type of data used in this, it will be video and image, as the technique of identifying one or multiple persons present in the video and based in the facial features. The camera detects and locates the image of the face either alone or in the crowd. The image is actually captured and analyzed. The technology mostly relies on 2D rather than 3D because it matches the 2D images with public images or those in the database. Difference between supervised and unsupervised learning. While supervised learning uses supervised learning algorithms are trained using labeled data, while unsupervised they are trained using unlabeled. Supervised learning takes direct feedback to check if the predicting is correct output or not, while unsupervised does not take direct feedback at all. In supervised learning, there are algorithms such as linear regression, there is decision tree, there is support vector system, while in unsupervised there are algorithms like clustering, PCA, and etc. In supervised learning, the input data is provided to the model along with the output, while in unsupervised learning, only the input data is provided to the model. Supervised learning techniques. The techniques I will be using here is CNN, which is convolutional neural network. The CNN model is developed to improve the accuracy of the face images, and it starts by pre-processing stage, which is color space conversion, then resizing the images, extraction of the facial features, and then classified afterwards. The face image processing is based on CNN collects a large number of pictures for the computer to learn, and after collecting the pictures, it crops out the irrelevant parts, and yeah, this is also known as pooling. Then flattening is also used to put the pooling output into one dimension matrix before further processing. Supervised learning continuation. And yeah, the second algorithm I will be using is decision tree algorithm. They are very powerful and attractive approach for classification and prediction. It is actually based on rules and helps in decision making. The rules can either be applied accordingly or even directly used in any computer language like SQL, Python, etc. And the other one is actually the flowchart for the algorithm, which is going to be loading the database, then it does the pre-processing and yeah, the extraction of the features. And also in the other side, there is image, loading the image, pre-processing the same, but it will be recognizing using decision tree and CVM, which is also another algorithm for the supervised learning. Unsupervised learning techniques. Here I'll be using independent component analysis and principal component analysis. Independent component analysis is a fast developing area in test research interest. It is performed on face images in the database under two architectures. One, it treats the image as random variables and the pixels as outcomes. And the second architecture is it treats the pixels as random variables and the images as outcomes. The first is actually found at the local basis images for the face, while the second produces a factorial code. The classifier that combines the two architectures gives the best performance. The second one is actually principal component analysis. This method finds a set of basis images and represents sets as a linear combination of those images. The basis of the information found by the PCA depends on pairwise relationships between pixels and image databases. In this task as face recognition, in which important information may be contained in higher order relationships among pixels and basic images, this method is the best. The technical challenges faced. The first is actually image resolution, which is the variation quality and the resolution of the image given as input is poor, and if the resolution is good, then the process will be much easier and efficient, but if it's not, then it's going to be hard to recognize people's face. The challenge of accuracy. Over time, changes in face make it difficult to match the photos taken earlier. The challenge of security. It poses a significant security threat to its users because it uses biometric data, which can be easily exploited for theft and other purposes. How to overcome these challenges? By using deep learning, as it extracts unique facial components from face images and uses trained model to identify the photos from the large database. Then another one is 3D imaging, which is in a way to get more accurate facial recognition results. And the third one is actually using data cloud, as data cloud works with continuous cybersecurity specialists and it strengthens the company's security. In this slide, we are going to be talking about accuracy, recall, precision, F1 score. Accuracy is defined as total correctly classified example given by a total number of classified examples. Let's take an example of an email being spam or not. In this case, if our model classifies a email sent by the boss being spam and does not show harmful or any other small amount of email being as spam, the formula of accuracy is true positive plus true negative divided by the total. Then recall, in this classification problem with two classes, recall is calculated as the number of true positive divided by the total number of true positive plus the negative. So in case of face detection, let's suppose there are 7 actual faces, but our model can only predict 5. So this is 5 divided by 7. And that's the formula. Recall equals to true positive divided by the predicted results. This is the continuation. Precision refers to the number of true positives divided by the total number of positive predictions. The formula is precision. The formula for precision is actually true positive divided by the actual results. Then for F1, it's actually, as we know, precision and recall, there is false positive and false negative, so it also considers both of them. F1 is usually more useful than accuracy, especially if you have an even class distribution. It works the best if false positive and false negative have similar costs. The formula for F1 is 2 into recall into precision divided by recall plus precision. The artificial intelligence evaluation matrices I'll be using in this project is precision and F1 score. Precision, in definition, it is defined as actual correct prediction divided by the total predictions made. So in simple language, let our project predict that out of 10 faces, 7 are predicted, and among the 7 predicted faces, only 3 matches the faces in the database. So in this case, precision is actually 7 divided by 3. And F1 score is one of the most important evaluation criteria in deep learning, and we will be using deep learning mostly in this system, and it is also known as the mean of precision and recall. It combines precision and recall into a single number. So that's why we'll be using F1 score also. This is the continuation. This is a flowchart of which is more accurate in detecting the test cases, which is precision and F1 score. This is the reference, those are the websites, and the last one is actually a textbook that I referred to in learning independent component analysis. Thank you.